So yeah, I guess we'll get started. I'll just let Casey take it away.
Cool. Okay. Yeah, let's see. So I made slides, believe it or not. Uh but I haven't like practiced or anything. So this is like in the uncanny valley between off the cuff riffing and prepared presentation.
This
It's
would be
the
a perfect time for Chris to be here.
it's going to be the worst of both worlds. So
So
as soon
here
as I
for it.
find the screen share button, I will. There
For
we
me,
go.
it's right
Boop.
next to the leave button at the bottom.
There we go. All right, we're in the Hall of Mirrors. It looks like.
Oh
Nice.
wow.
Max and I got a little bit of that yesterday with a Slack huddle.
Oh, nice.
Was that yesterday? Time has no meaning.
It was yesterday, yeah.
All right. Can you see the slides in presentation mode right now?
Yes, I see a lot of pink and I'm already thrilled. Your presentation is A plus and approved.
Cool.
What did you call it again? What was the first word?
The color scheme is vaporwave hot dog stand. So
Like, nice. Okay,
these are the colors.
okay, good.
Yeah. So enjoy that. Maybe turn your monitor brightness down.
I was gonna say,
Just
I
a
think we
warning.
may need a seizure warning on this episode.
Oh yeah, I was flipping back and forth there kind of quick, wasn't I? There's no like animation or anything, so that should be the only time that happens. I can't see any like
People.
people when I have this full screen on my screen. So if you have a question or a comment or whatever, just go ahead and interject. Um,
I can see people though, so if someone wants to raise their hand, I can be your whatever, your proctor. Is that a word?
sure. Yeah. Sounds good. Okay, cool. Uh, yeah, so the topic today is basically just like stuff that I learned about ClojureScript after doing my first like actual project in it. So let's talk a little bit about it. And hopefully the kind of idea here is like obviously ClojureScript is kind of a niche topic. So I'll talk a little bit about specific ClojureScript stuff, but then maybe there will be a chance to branch the discussion out into more broadly like stuff that you've noticed well in an unfamiliar programming environment or stuff like that. So anyway, here's the background. I made a game in ClojureScript. It looks kind of like this. It's called CounterSpell. And you can play it right over here. You can play it right now if you want. So I expect at this point I'll lose at least one or two people for the rest of the talk to just playing Counterspell.
I was actually really tempted, but I promised to monitor stuff. So
And in fact, just for illumination purposes, I'll run you through a quick game of it. So Counterspell is a little word game kind of inspired by the likes of strands, if you know that from NYT games or crosswords, whatever. And the idea is you get a grid of letters and you can spell words by clicking them in order. So let's see. I see a word here, give, and a legal move is anything orthogonal or diagonal from the tail of the word that you're spelling. So I could go to this I. From here, I could go to this V, and then here I can go diagonally down to this, and I spelled give. And if you click the last letter a second time, those tiles disappear, and then new tiles fall in to take its place. And I can do that a couple more times. I see say here, and let's see. I see mug. And after you do it 3 times, um, the game takes a look at what is left on the board and Scrabble scores everything. And then totals up your Scrabble score. And the goal is to get the lowest score possible. So the idea is you're kind of looking ahead. Where will tiles fall? Can I spell words such that there won't be high scoring words left on the board after my third move? So that is Counterspell. And I made that for the Spring Lisp Game Jam that happened a little bit ago. And I chose to do it in Clojurescript because I've been trying to learn Clojure this year, and I have just been doing like little advent of code problems and stuff like that. I haven't really done anything real with Clojure yet, so I thought, hey, this is a good opportunity to do something real. And you can take a look at the source code. It's on GitHub there, github.com/basecase/counterspell. You probably shouldn't look at it. It's very bad. Yeah, this was my first real project with Clojure, and it was very interesting because I think this is probably the biggest difference in terms of what I'm familiar with and what I'm not familiar with in terms of languages. I've written code in a whole lot of different programming languages, and obviously every language has kind of its own view of the world and its own concepts and stuff. But I think, basically since like college, I think going to Clojure from the stuff that I'm more familiar with has been the largest conceptual leap for me out of the familiar. And so because of that, I encountered some, surprising stuff, some things that I hadn't anticipated, or, you experience the thing of like you read the documentation on something and you think you understand it, and then you actually try to go use it in anger and realize that your understanding was flawed or inadequate or whatever. So just a real quick rundown. We can kind of rush through this just to get familiar. I'll share a little bit of code later, and just this is not like a primer on the language, really. It's just so that you're sort of familiar with how it looks. So here's some JavaScript. We're defining a couple of variables there, a and b. Then we define a function called add. It returns the value of x plus y. And then at the last line, we call the function add with the variables we defined. And here's what the same thing looks like in Clojure. And I should mention, I don't think I've said this yet, Clojurescript is a dialect of Clojure, which is, in its original implementation, a Lisp that runs on top of the Java virtual machine. Clojurescript is the same programming language, but it targets JavaScript instead. So the Clojurescript compiler outputs JavaScript code that you would run in a browser or on Node or whatever. And so this is what the same thing looks like. That def keyword is kind of like let or const. I'm just defining variables there. And then def n is define function. I'm defining the function add. Those square brackets are the arguments for the function. And then the thing that is, I think, most surprising to people when they're looking at Lisps for the first time is to call a function, you use these parentheses, and the first thing inside the parentheses is the function that you're calling. So in this case, I'm calling the function plus there on that fourth line, and then the function add that I just defined on the last line. And it just looks like a list of stuff, but the interpreter knows that the first thing in that Lisp is a function, and the other things in it are arguments. So it just looks a little weird. It can kind of trip people up if it's the first time seeing it. So I just wanted to show side by side here. I also chose to use the library Reagent, which is a Clojurescript wrapper around React JS. And I'm pretty familiar with React, so I thought maybe this would give me a leg up in terms of actually getting something shipped in the space of a game jam. So here's some React code. I'm defining a component there on the left side using the JSX syntax. And then I'm using it on the bottom three lines there. You just use those angle brackets. You can treat a React component like it's HTML, more or less. And in Reagent, it looks like this. You just define components using the same syntax that you define other data structures in Clojurescript. So those square brackets are a vector, which is, there's more to it, but you can roughly think of it as like an array. And it is just the Reagent way of thinking about this. Actually, the syntax is called Hiccup because there are other templating engines that can use this same kind of syntax where the first member of the vector is just a keyword that maps to an HTML element or a component name or whatever. And then you're basically just defining your HTML as these arrays of keywords. And it's pretty nice. That has some really nice properties for when you're trying to edit like big lists of HTML. So anyway, that's just kind of what that looks like. Again, this is not meant to be a comprehensive tutorial on these things. It's just so that your eyeballs are a little bit more used to what these things look like. So real quick, mostly what I want to talk about today is what didn't go very well, but let's talk about what went reasonably well on the first time out. Interactive development is kind of the thing that people who are Clojure and more generally Lisp enthusiasts always talk about as like, what are they so excited about with Lisp? I mean, Lisps have a lot of interesting properties that set them apart from other languages. And you can debate all day long what's good, what's not good. But interactive development, I think, is the thing that people really talk about basically exclusively in a positive way. So let me show you a quick demo of what that looks like. So the whole idea with interactive development is you are taking the notion of a REPL, the read eval print loop, which other languages that we work with like JavaScript and Ruby and Python have this notion where you can open up a terminal session and you've got interactive Ruby like IRB or whatever. You can type expressions in there, evaluate them, and get the results back right away. Lisps take that notion sort of all the way to its logical conclusion and have your text editor and the running session connected to each other at all times. So I showed you this game. I've got it running here in my browser in localhost, but I also actually have it connected to my editor at the same time. So I can do some really neat stuff like that. Don't look at any of that code. That's all pretty bad. But I can evaluate expressions, of course, just like IRB or whatever. So this is, again, this is the function in the first position here in the list, and I'm adding two numbers together. If I evaluate that, I see that it's 2. But I can do some interesting stuff. Like, for example, I have all of my application state in this atom, ATOM. That's just another Clojure thing. Don't worry about it exactly what it is. It's just a place for state to live. I can actually inspect that from the running app in my editor. So this is the editor that's defining my application. It's not like a separate window or anything. And I can take a look. When I evaluate that, selected grid spaces, that's an empty vector right now. And if I select something and check it again, it's pulling it from the same place. It's not like running that code separately. It's running it in the same session. So I can see that I selected this F at position 1, 2. Add a couple more things on there. FYQ, FYQ. Yep, that's the same thing. And it goes both ways too, right? So I can use this swap function, which is just the way that you update an atom. And I'm going to update that same thing, selected grid spaces. And I'm going to use this function but last, which is a funny little function that's in the standard library that basically gives you back a list with everything except the last thing in it. So let me run that. And the response here is big just because it's the whole app state. But if I come back over here, the queue isn't selected anymore. So that's interactive development. And that has a lot of very cool implications for your coding process. Basically, it just, we always talk about tight feedback loops. That's something that you hear TDD practitioners talk about all the time, is like, you want your feedback loop, you want your time between typing some code and running that code to be pretty small, because then you're sort of always checking yourself and always making sure that your mental model and what you're actually writing in your code match up pretty well. And interactive development this way with Lisps and with Clojure tightens that feedback loop basically like almost as small as you could imagine it being. And that's really cool. It is a very interesting feeling to code that way, especially if you're coming from languages where the feedback loops are bigger. I'm going to take a sip of coffee. Hopefully this doesn't like trigger anybody's misophonia.
I like the notes in your slide here.
Mm-hmm. Yeah, it's important to keep helpful notes to yourself.
Great.
Other things that went really well, structural editing. I won't rehash this because we actually had another discussion where we went into this in Dev Roundtable, but basically the idea of like Lisp code again. How does Keynote work? Lisp code has all these parentheses, and you've got these nested lists everywhere that's describing the tree structure of your program. And if you're just trying to use that the way that you type in Ruby or something like that, it can get kind of hairy. But structural editing modes are ways to navigate those trees and edit those trees really fluently. So when I was doing well with that, it felt really good. It's very a very fluent way to edit things. I haven't had a lot of time practicing that yet, so I often fell back to my old habits, and that was less nice when that happened. But it's pretty cool. And the last thing that I thought worked really well right out of the box for me was Clojure's built-in data structures are all immutable, which means you define them once, and if you've got a reference to, like, say, a vector that you defined somewhere, you can count on that reference always referring to the same vector. It'll never change out from under you. So even if somebody else gets another reference to that same vector, they can't change your view of the world. So it sort of just solves for free a whole big category of errors that you can have if you've got aliases to the same data structure and multiple places are editing it. And the way that React likes to think about its component tree gels really nicely with the way Clojure likes to think of its data structures. And that's expressed very well in the reagent wrapper library. So those things I thought really went well. More stuff didn't go well than went well, though, I would say. And the first thing that I want to talk about is I'm going to talk about two sort of categories of error that I made. One is a mental model error where I just didn't understand clearly enough what I was trying to think about. And then the second one is less about understanding and more about tactics, just like the way that I approached coding that could have been better. So we'll start with the bigger one, the mental model error. And that is me getting tripped up on Clojure's seeks, S-E-Q. Seeks it's short for sequence, and it's sort of one of the central organizing ideas behind Clojure's standard library. A seek is a logical list, but it's specifically an abstraction, not a concretion. So like a vector or a list or one of the inherited JavaScript or Java data types that Clojure is sitting on top of, or network streams or like event sources that you're reading from. Those are all notionally sequential sources of data. But they all have different interfaces, different APIs, and different ways of working with them. But the seek abstraction unifies the way of working with that stuff. So its core definitions are the function first, which gives you the first thing from the list or the vector or the network stream or whatever, and rest, which gives you everything else, everything after the first thing. And that sounds sort of like too simple, but the ramifications of this are actually extremely powerful and extremely interesting. And it means that the Clojure standard library, which defines a ton of functions for slicing and dicing seeks in different ways, they can all work without any additional change on your code's part with all of these different sources of things. And crucially, they're lazy, which means they'll only evaluate members of the seek that you're asking about specifically. So if you say first, then it's going to evaluate the first thing on there. If you say there's a function called take, which takes a number and a seek and gives you that many elements out of the seek. So if you say take 5s, then it's only going to evaluate 5 of those things, not the whole list or array. Contrast this with like a JavaScript array. If you call array.map, if you've got a function that transforms every element of that array, it's going to run all of those functions for every element right when you say that eagerly. the laziness of seeks allows the same abstraction to work for vectors right there in memory, and also like network streams that you don't know how long they are, or maybe they're even infinite. And it doesn't matter, it won't lock up your program if you're using this seek abstraction well. So seeks are really cool.
Sorry,
Yeah.
I just want to interrupt because I think that there's something. Oh, more demo here. Don't forget to delete these. Um, there's something in my mind, and I'm wondering if this is where you get into the mental model problem. Like it's similar to Ruby has the enumerable module,
Yeah.
and it's included in a lot of things, and then you can include it in your own class to make it act like that. It does more than first and rest, but like I think also there are certain things like if you really want it to work, all you have to do is define like each or something, and everything within the module is defined based on that.
Mm-hmm.
And then only recently, take recently with a grain of salt, but like only recently, um, Ruby had like the idea of lazy stuff, and it would return like you could you could have it return an enumerable, like, and just build stuff up like that, as
Yeah.
opposed to actually do it all. Is that kind of
Yeah.
where
That's
where your mental model and my mental model is failing, or is it actually more correct than?
No, no. Yeah, that's a great analogy, and I think is, by my understanding, that's a great reference point for the seek abstraction. And I'm really glad you brought it up, because I actually had a note to myself, a real note, not a joke note,
Yeah.
that I intended to mention Ruby's enumerable as like a comparison point, and I totally slipped my mind. So I'm really glad you brought it up. It really is a lot like that, and seeks are very similar to that enumerable abstraction. And then basically, like, all of the other methods defined in enumerable, that's kind of like the Clojure standard library. And so, like, you get sort of just, this is just a design decision, but you get, it's something like 600 and something functions. Now, they're not all about seeks. They're basically like all of the core functionality of Clojure, but they just sort of sit there in the core namespace, and you've got access to them, as top level things, if you're just programming normally. And that's sort of like where the rest of the enumerable methods come from. It's just the standard library. But yeah, that's a great reference point. That's very similar, and so that's also a thing that can trip you up, both in Ruby and Clojure. Is enumerable and seek are both awesome, but you can't always forget about the data underneath them. Abstractions are great, and I'm jumping the gun a little bit, but yeah, actually, let me just get there. So let's talk about vectors real quick. Vectors are one of the core Clojure data types. They're conceptually immutable arrays. The way that they're implemented is actually is fascinating. If you're into like data structures and algorithms, take a look at how Clojure does this. Because it's really interesting. Basically, it gives you that immutable behavior that I was talking about, of like, I've got a variable that references an array or a vector, and I can trust that my reference to that vector is always going to look the same no matter what the rest of my program does. But we can also make changing those arrays, which I keep saying array, changing those vectors fast, like reasonably fast, not quite as fast as like a native array of integers on, in C or whatever, but still very fast. And the algorithms behind making that work are pretty cool. And that's, one of the default types in Clojure is this vector. They are seekable, which means you can have a seek abstraction over a vector, just like you can with lists and network streams and a whole bunch of other stuff. But crucially, they are associative, which is not a property of seeks. So remember how I said with seeks, you care about the whole seek or the first thing or the rest of it, basically. With vectors, you can care about any position on them, just like, an array. So here's another quick demo. Um, what have I got here? So I'm going to define stuff. I've just defined a variable called stuff, which is a vector of 3 symbols here, or 3 keywords. The colon syntax is a keyword in Clojure. And I can use this function called assoc to associate inside an associative object at the key that I give it a value. So if I run that, I get a new vector back called that looks like this. It's got A, and then at position 1, since we're 0 indexed, the high is there and the C is in the last position. So associative means that we're mapping between keys and values. So that may trigger a thought of something, well, hash maps, what's that? That's the classical associative data structure, is we're mapping keys to values. But Clojure takes this idea a step further and says, since vectors are mapping keys that are integers, like position integers, to values, they also are associative. So this assoc function also works with maps the same way that it works with vectors.
I did Clojure professionally for 3 years, and I did not know you could do assoc with vectors.
Oh, nice. Oh, we're dropping some hot tips here.
And I feel like a lot of things just made sense in my life.
Nice. Awesome. Happy to share some hot tips here. So this assoc thing is very cool. Let's take this a step further. Now I'm going to define a more complicated vector. This is a 2D vector, or it's a vector of vectors, right? So I called it grid. This is very similar to the game board state that I'm defining for my game, which is a grid of letters. And there's another function called assoc in, which lets you actually give a vector of keys to traverse. So with assoc in, it's expecting to receive a nested associative structure. So like a map of maps, or like if you think of like some nested JSON is the classical nested associative structure, right? And you give it a vector and it'll traverse those keys in the order that you give it. So here I said 1, 2, and the result of that is this first vector is unchanged. The second vector, that's position 1, at its third item is changed to this high, and then the third vector is unchanged because I said, all right, I didn't care about it. So assoc in is very cool, especially if you've got like I said, deeply nested JSON or whatever. And then we can take it a step further. So this is really what my grid is actually looking like. It's a vector of vectors of maps. So we've got the letter that's at the tile position, but then also things like the state of the tile. Is it selected or not selected? Is it falling in after tiles were cleared? That sort of thing. And assoc in, the vector that you give it, works with any associative structure nested in any way that you want. So in this case, I'm traversing 2 vectors and then a map, and that is just fine. Clojure says that's totally cool. And this is a little hard to read because again the structure is kind of big, so the scroll back is tough here. But you can see it did the right thing. The state here is set to active. So you can imagine this kind of thing is really handy for working with a game that's totally based around this grid of letter tiles. So what was my mental model mistake? How's my time looking? That was about half an hour. Okay, I'll try to speed up a little. I think the second chunk is smaller than the first chunk also. My mental model mistake was conflating seek and vector. I read about the sequence abstraction when I was reading Clojure docs and trying to get up to speed with the language. And I was like, oh, sick. That's cool. What I'm reading is you always want to think about seeks, like always work at the level of seeks. And that is not true. They are not interchangeable. The abstraction goes one way, right? Just like interfaces, just like any abstraction, you don't treat them as interchangeable. You treat one as a nicer, sometimes, interface onto the other. So this led to a lot of confusion, not nailing down right at the beginning of the project. This is a vector of vectors. That's how you make a grid when you care about specific coordinates inside that grid. Not nailing that down right away led to a lot of confusion because first of all, just because I was sort of confused about the data structures, but then also because the Clojure standard library functions that work at the seek abstraction always return seeks. So again, that take function that I mentioned, take 5 things out of this seek, no matter what you give it, you are going to get a seek back. And that's how abstractions work, right? Like if you want to work at the level of abstractions, you stay at that level. And if you pull something specific up to that level of abstraction, that's going to be your minimum level as long as you're working with those things, unless you explicitly cast back down to a vector. So this led to a lot of confusion and a lot of rework. So the lesson that I took away from this was data matters, right? Like we spent a lot of time talking about these abstractions. Seek is really cool. I think it's just a brilliant piece of language design and library design. The insight that Rich Hickey had to say, let me collect these things together in this particular way that just feels so simple and so elemental, and use that as an organizing principle for a huge amount of the language. That's really cool, but it has some sharp edges if you don't totally understand exactly what is going on there. And the takeaway for me was, don't allow those abstractions to let you forget about the concrete shape of your program's data, because that's really important. And you can work at a higher level some of the time, but you can't punt on figuring out that concrete actual shape. Okay, that was part 1. I'm going to take another sip here. So that, I think that was sort of the more important error. I think it was a mental model error. Just I don't totally understand this language yet. I'm trying to write JavaScript in Clojurescript still. I haven't really completely wrapped my mind around all the ramifications of this idea. The second one here is less about that and more just about a tactical error. And then it was really interesting to kind of watch myself work during this game jam, because I've written a lot of JavaScript code. I've written a lot of React code. And so I was kind of thinking, oh, I can just hop over to this other language and this other framework for this game jam, and like, it'll be no big deal. What wound up happening was I kept finding myself making mistakes that I would never make while writing JavaScript, just because I was in an unfamiliar place. So, excuse me. So my habits, some of them sort of fell apart while I was working, just because it was an unfamiliar place. So let's talk about functions, and specifically making small functions. We always talk about small functions, small methods, single purpose things. We want objects that do one thing, methods that do one thing, tests that only test one thing. We want to try to keep our units small and keep things really tightly scoped. But there's a sweet spot, right? Like, you can get ridiculous with this. If you're writing Ruby and every single one of your methods is only 1 line long, like, that's a little bit of a code smell in its own. Now, you can do it, right? And some code bases do this and wind up being fine. But it's more of like a North Star, right? It's like, we want our methods to be small, but you can bundle a few things together, or you can like use a few lines of code to accomplish one thing. You don't want to take it to an absurd extreme. In functional programming, I'm finding, at least for my money, and this is a bit of a relative thing, so your mileage may vary, but the average size of my JavaScript functions is bigger than the average size of what I expect will be my Clojure functions going forward. In functional programming, we're thinking about functions, and that's the unit that we want to be thinking about all the time. And it's actually reasonable in Clojure to push that a lot smaller than I was used to. So let's talk about let. That is Clojure's mechanism for scare quotes local, scare quotes variables. So let me show you what let looks like. So I'm going to explain every line of this. Don't worry, it looks a little weird at first, but let is basically, you establish a new context with let. the first argument to let is this vector, and it's a vector of pairs of things. And every even numbered thing inside this, they call it the bindings, is going to be a name that you want to work with. So we can think of that as a local variable. And every odd numbered thing in here is going to be a value. And these values are getting bound to these names. So nums, let nums 1, 2, 3, 4, 5, 6 is saying within this let block, give me a variable named nums that has the value vector 1 through 6. And this is local, so nums is not going to exist outside of this let block. So you can see it ends here. By the way, this is the thing Lisp programmers do. They don't do like C style where you put your closing brace on its own line. They always put all the closing braces all together at the end of a line because there are often a whole lot of closing braces in Lisp code, so they stick them all together. But this is just the same thing as this, so don't get too confused by that. But basically, inside these brackets here, nums is going to be this vector, and it's not going to exist outside of there. And that is basically the primary mechanism for working with like local state or helper variables or whatever in Clojure code. These also run in order, so I can define things lower down in this let bindings list in terms of things earlier in it. So I can say nums is this vector, and then x's is the same thing as nums, and why I did that will become clear in a second. And then after this vector is a form, and it will evaluate this and return its value in terms of these bindings that you give it. So in this case, I'm saying apply plus 2 x's, and apply is just a way to treat a list as though it's positional args to a function. So this plus function can take as many args as you want to give it, but it takes them just as like function arguments. So apply plus is just saying turn that into a function that takes a vector instead. So if I evaluate that, it's the sum of 1 through 6. And I can do other stuff in here. And in fact, this is a very common pattern in Clojure code is you sort of build up your calculation that you want to do in terms of these intermediate variables. Just like in JavaScript or in Ruby or whatever, you can introduce these helper variables to kind of attach names to individual concepts. So let's do something like this. Let's call it like I'm going to make let's introduce a new one called filtered, and we're going to filter on the function even nums. And so what that's doing is saying, I only want 2, 4, and 6, and the sum of 2, 4, and 6 is 12. So that makes sense. And actually, let me actually define a little helper function here. I'm going to call it my filter because I want my filter to be a little more complicated. And so that's going to be a function. It's going to take one value, and I want it to say you get through the filter if you're even and also you're less than 5. So now this should be, the end result here should be 6. So let me just change this. I'm changing the filtering function on filter, and the result is 6 because now I'm applying this my filter function. And this is getting a little hairy, right? Like you could imagine, especially if I introduce some better formatting here, like, let's put these all on their own line. Like this is kind of gnarly, right? Like this is this weird little pocket. This function definition is this weird little pocket here that's kind of hanging out on the right side. There's all this white space to the left. It like sort of throws off the flow here. You kind of lose track of like what is going on. And you can do this. Clojure doesn't stop you from doing this, but this let form kind of punishes you visually for doing too much of this. Like if you define too complicated of a function here, then you've just kind of lost the plot. It's just too hard to look at. So what's better than this? Well, just define a function. Let's define a function called myFilter. It's going to do the same thing. the same thing. And check this out. I just defined this function up here at the top level, and I was raving about interactive programming before. Well, I can just test it right here on its own to make sure that I wrote the right thing. So let me just test my filter. Four should get through there, right? Yeah, okay, that's true. 3 shouldn't because it's odd, and 6 shouldn't because it's even but too big. Yeah, okay, nice. That works. So let me just get rid of that goofy extra thing. Okay, it works better. I've got this little helper function, and this let block is a lot cleaner. So let sort of encourages you to define these smaller functions. And in general, everything about writing Clojure and Lisps in general encourage you to write these tiny functions. So in JavaScript, the way that I tend to approach problems is I'll write a big function that's way too big and conflates too many concerns. And then once I've got that working, I'll look at it and it'll be like, oh, I can pull out like this. I can refactor this piece. Oh, I can introduce a helper variable here. Oh, this is duplicative. I can refactor this. I can pull these things out. So I write a big messy first draft, and then I pull out the small pieces, and that works fine. That's a fine way to write JavaScript. I also tend to think more in terms of like helper variables rather than functions a lot of the times if I'm like one big algorithm or whatever. And I would categorize that as kind of a mistake in Clojure. So the lesson here is ABC. Always be functions. You want to focus on these smaller functions. And again, we always talk about these small functions in any language, right? But in Clojure and Lisps in general, they are really the fundamental unit of stuff. And it's so cheap and so easy to write functions, and you're rewarded for writing these small functions with interactive development because the feedback loop on making sure you wrote the right thing for this tiny little conceptual unit is so fast and, fun also. And my mistake was starting with the big and then compressing down to the small rather than starting with the small and then building the big out of the small. And there's a lot of benefits to doing it this way. One of the big ones is, I was talking about getting confused about seeks versus vectors. Well, you can sort of accrete an abstraction layer around your concrete data by writing these small functions. So, you can write a small function that is basically nothing but a wrapper around assoc or assoc in, like I was showing. I could write a little function that's like, set tile active at, and the definition of set tile active is basically that code that I just showed you. And that's an itty bitty little function, right? Like so small as to be almost like, why would I even make that? But I think that Clojure is pushing you to do that. And I think that the next time I write a serious Clojure program, I want to lean into doing that right away. Rather than writing this big blob of code, I want to say, oh, I notice that I'm trying to define a concept or like put a name on this traversal of my data structure. Just make a function. Go ahead and just make a function that does that. And we also talk about like reuse with functions. If you can reuse a function that you wrote this way, that's cool. I mean, that feels really neat when you can reuse something you wrote 6 hours ago and be like, oh, nice, I already solved this. But it's also okay if you can't. Like if you write one of these tiny functions and the only thing it does is put a carefully considered name around one of your concepts for your domain and your data, that's a huge win even on its own. It doesn't have to also be like reusable or whatever.
I just wanted to. Oh, good discussion.
That's it. That's the last thing I had to
time.
say. So,
I just wanted to say about that part is, I mean, you're terrible, Casey. I love it.
I'm so here for it.
The naming thing is a big deal. I used to when I worked with Rick Bradley, sometimes we would pair on stuff, and I would be like extracting, especially when we were seeing other people's code, and we're like extracting big blocks because you're like, this is just so confusing. And it's not even about reuse. It's, as you say, like having like a concept that's encapsulated there. And especially when you're looking through something and you're like, this is defining some variable, like all this stuff happens, and then in the middle, this is defines some variables and it operates on those, and then returns a result, like you computes a result, and then none of these variables are used anymore. You're like, well, perfect to extract that. Um, and I would be really good at that, and Rick would be the one to name everything because I'd be like, I don't know, this is like do some stuff. I can't think about it. But it is interesting. I don't think I've gotten to the point where I do it with really small stuff, maybe because I'm not using a Lisp. Um, but I think I've definitely started with like, okay, here's something that I'm doing, and then here's some important calculation, but it's not really important what happens inside. I want to sort of like black box it. So I just write the function, like the function call, and I move on. And then later I have to define that function. Right. And I think working with Macs, I've seen some stuff where it's very like doing some stuff. You lay out the steps with comments, and it's that sort of thing. It's like, what, there are 4 steps here, right? Sure, step 3 is huge, but it's still 4 steps, and we'll get back to that. Yeah, I think it also came up with in one of the videos that I've linked in the channel, like Sebastian Lang or Longa or whatever, and his coding adventures. And he talks about like, yeah, this is one of my favorite tricks, is just call a function that doesn't exist yet. Yeah.
Yeah. Yeah. So I thought for discussion purposes, I mean, I'm happy to answer any questions that anybody had about what I talked about, but I'm also interested in hearing about times you've had similar experiences where you sort of like went into an unfamiliar, framework or language or whatever, and you were kind of like some of your old habits didn't serve you in that environment or whatever. But Jim, I thought I saw a hand up.
Yeah, I was just going to add pin onto the end of Yosef's comment, which is that's what ChatGPT does as well. It's like, I'm just going to make up this thing and like it'll exist eventually.
Are you calling me
only-
ChatGPT? Is that what I'm hearing?
No, I'm just saying ChatGPT is very human.
It's
just
well,
Sure.
it just feeds on our input. So
yeah. So I a lot of what you were talking about mostly relates to learning other languages. Right now I'm learning Spanish, and so lots of things that just not understanding some of the core concepts makes me make much longer go much further around than I would if I actually understood more of the language.
Absolutely. Yeah. Same thing I think applies to spoken. I remember my partner and I visited France many years ago, and if you know anything about French, you know that the way that they count is just completely bananas. The way that you say numbers in French just doesn't make any dang sense. And another thing that happens in France in a lot of hotels is they still do the old style. You leave your room key with the front desk of the hotel. You don't take it with you when you go out and about.
I'm here for
And
that.
I have this burned in memory of me striding confidently up to the front desk. I had been like rehearsing in my mind. I was like, I'm going to say the name of our room in French, or like the room number in French, and it's going to sound great. And I'm going to be so proud of myself. And then I just say the way that I would say it in English, but converting each word to French, which that computes to not a number in French.
Right.
And the desk clerk was just like,
Type error.
Nan, what is this? And my partner had to come up and save me with the actual correct thing.
I have 2 thoughts. One is I have used Clojurescript. I think you actually have a more positive opinion of it than I do. The one thing which you already said, but I just want to reiterate, is that the thing I long for again from it is the ability to, I think I say this every time, is editing JSX like a Lisp. Um, I'm just going to keep saying it until someone fixes my problem. I don't know. It's going to be one of you, I guess, now. Um, but so the term for talking around a thing is circumlocution. And I feel like I do that in a number of the other languages I speak, but also like, and exactly in programming languages too, where I'm like, I can write, and like Clojure is probably a good example of this, where like I can write Clojure. I've done it professionally. Probably someone who's very good at Clojure, reading my Clojure is like, yeah, you've written a lot of JavaScript. Because I probably write it like a JavaScript programmer. I can write it. I can make things happen, right? Like, not to be that guy, but like it's Turing complete. I can get it to do the thing. It's certainly not idiomatic. It probably reads funny. I can get it to work. And I feel like that's just such an important thing to be aware of. Not that like, I don't know, I get itchy when people are like, you have to write completely idiomatically. I'm like, eh, there's a time and a place, but also if you're not, if you, well, I don't know how you would even write Clojure avoiding seeks, right? Like that's such a perfect example. And one of the issues I had was over and over because I didn't understand laziness at a core level. I would be sitting here being like, why is nothing happening? Why is nothing happening? And I'd ask for help. And one of my coworkers would be like, you're not realizing it. Like nothing is happening because nothing is happening. I'm like, yes.
Yeah, classic example of somebody putting a bunch
But
of print lines in their seek code and like, how come it's not printing?
right, exactly. And I'd be like, what isn't happening? And they're like, you need to realize, like, it needs to evaluate. I'm like, yes, I agree. Um, but yeah, just in other languages, the experience of like, I know how to do it in this other language. I will try and do it the same way. Sometimes that will work, and sometimes you just end up with a really roundabout solution that because you're a programmer who has programmed in other languages, you come up with a functioning solution. And maybe it's the equivalent of you're at the grocery store in France and you ask for like the long orange triangle vegetable. And they're like, a carrot, and you're like, I don't know that word. And they're like, this. And you're like, yes, that. You know it when you see it, but you're standing there going, I need the long orange triangle vegetable. And they're like, yeah, okay. I don't know.
I just had to comment on the bit of when you're talking about you do all this writing code and then you get a functioning solution, but you don't get a functional solution. That's what we're going for here. But yeah, I mean, I know in my career, it's like I learned C young, and then I did Perl, and my original Perl was like C with sigils, right? And then I got really good at that, and then I went to Ruby, and at the very beginning it was just like weird Perl stuff, but in Ruby, and then I got really good at that, and by really good at like doing it correctly, is not really good at writing Perl in Ruby, and then I was on this Elixir project with Max, and at the beginning I was like, what happened, and then again get good at it. And just speaking of from the very beginning and closing the loop is one of the things I really like about Elixir is like the pipeline stuff. And then you can pipe it to debug and it doesn't just print out, it understands pipelines. So it doesn't just say, blah, 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 and then here's the value, is it tells you the value at every single step.
Mm-hmm.
And sometimes I would specifically write stuff as a pipeline, even though it could just be a couple of functions, because I wanted to do one debug and see the steps. And that's not quite closing the loop because you still have to like look at the output in your server or whatever. But it does help you see everything as opposed to like, okay, well, I see there's a problem here. Let me start putting some more debug statements further up, right? And hone in on it. It's like, no, you can see every step. So
Nice.
that was very valuable, and just doing it right in the editor would be even better. think
Cool.
we only have a couple more minutes. Got to say thanks to Casey again for all this good stuff.
Oh yeah, thanks for letting me gab at you. I really wanted to once I finished the game jam, I really wanted to take some time to like do a little personal retro on it because I knew that there was a bunch of stuff in there that I could probably excavate if I took some time to think about it, but that I wouldn't get if I just left it at while I was scrambling to finish up the game by the jam deadline. So this was a good opportunity to go back through and kind of dig out the good stuff.
Nice.
I have like 10 times as much material in my notes that I found from reviewing everything, but I decided the way that I talk about things, I should probably scope it pretty small for 1 hour of presentation. Cool.
Thanks, Casey.
Thanks a lot. We'll see you all next time. And remember, leave your browsers open for a little bit to keep the upload going.
Oh,
Cool.
I can do that. Okay.
Yeah.
See ya.
Glad you said that. Bye.
Yeah.